Hey everyone, in this video we're going to be talking about how to find the sum and difference of various trig functions. So we're going to be utilizing the sum and difference formulas. Alright, so here are your sum and difference formulas, and I'll scroll down in just a moment. So notice that if you have sine of two angles, if they're being added, you're just going to follow the symbol that's up top. So you'll do sine of the first angle times cosine of the second angle plus cosine of the first angle times sine of the second angle. If it's a minus sign in between your two angles for sine, you're going to subtract those two. For cosine, it's a little bit different. So if you have two angles that are being added with cosine, so cosine of two angles being added, you're going to follow what's on top, but notice there's a minus sign. Also notice you have cosine times cosine of the two angles and sine times sine of those two angles. Okay, so the formulas look a little bit different. Tangent is kind of a combination of both of those. And sorry, I forgot to mention, if it's minus, we're obviously going to be adding in the middle for cosine. For tangent, if you're adding two angles, all right, notice you're going to add up top, but you're going to subtract down below. So you have the same sign up top, but the opposite sign down below. And then if it's minus, same thing. You subtract up top, add down below. All right, so just a reminder, what we can do is we can always look at the angle, and if it's an angle that we're not necessarily familiar with, it's not on our typical unit circle, we can just break it up into angles that we're more comfortable with. So sine of 90 degrees is equivalent to sine of 60 plus 30 degrees. However, sine of 30 degrees plus sine of 60 degrees is not the same thing as sine of 30 degrees plus 60 degrees. So here's our first example. We've got cosine of 15 degrees. Now 15 degrees is not our typical unit circle value, right? We don't know what coordinates off the top of our head, what values. So what we're going to do is we're going to rewrite 15. So if you take your unit circle, all right, and you think about some of your degree measurements on it, so it might be helpful. We did at the start of our lesson a warm-up on this. We found all the degree measurements for, sorry, this is a terrible unit circle, but that's awful. But anyway, we found all the degree measurements and radian measurements for every typical spot on our unit circle. And two things should come to mind when you think about 15 degrees. Either you could do 60 minus 45 or 45 minus 30. Either one is fine. They're both equivalent. So cosine of 15, let's do 45 and 30, is cosine of 45 minus 30. So we're going to use the cosine formula. We are subtracting our two angles, which means we are going to add in the middle. So now we're just plugging it into the formula. So cosine of 45 degrees, cosine of 30 degrees, plus sine of 45 degrees, sine of 30 degrees. Remember, 45 is the same as pi over 4. 30 degrees is the same as pi over 6. So these are really easy, should come to mind pretty quickly. So cosine of 45 is the square root of 2 over 2. And cosine of 30 degrees is the square root of 3 over 2. Sine of 45 is the square root of 2 over 2. Sine of 30 is, whoops, not square root of anything. Sine of 30 is 1/2. Then we multiply. So when you multiply radicals, as long as they have the same index, so like they're both square roots, cube roots, fourth roots, whatever you're working with, you can just multiply the numbers underneath. And then square root of 2 times 1 is square root of 2. And 2 times 2 is 4. Now the only thing we can do with that is we can put it into one fraction. So square root of 6 plus square root of 2 over 4 is our exact answer. All right, so now we're going to find tangent of 15 degrees. Again, 15 degrees, not typical on the unit circle, so we're going to change it up, and we're going to say, okay, well, 15 degrees is the same as 45 minus 30. All right, so here we are going to use our tangent formula. Remember, tangent is the same sign on top and opposite on the bottom. So we're going to have tangent of 45 minus tangent of 30 over 1 plus tangent of 45 tangent of 30. Okay. Now, tangent of 45, or pi over 4, you should remember is actually 1, since the x and y coordinates are root 2 over 2 and root 2 over 2. For tangent of 30, or pi over 6, remember the coordinates for pi over 6 are root 3 over 2, comma 1/2. So the tangent, you're going to do y divided by x, keep change, flip. And then you're going to have to rationalize by multiplying by the square root of 3 over the square root of 3. So tangent of 30 degrees is root 3 over 3. Denominator, we've got the 1. We've got 1 times tangent of 30, and we just figured out tangent of 30 was the square root of 3 over 3. Now, we're dealing with these fractions here on top and bottom, so let's make them not fractions anymore. So to do that, we're going to multiply the top and bottom by 3, right? The reciprocal of 1/3. Okay? And just distribute your 3 through. So we'll have a 3 minus the square root of 3, right? Because these 3's will cancel each other when I multiply that. And we'll have 3 plus the square root of 3. You should remember from Algebra 2 days, you can't leave a radical in the denominator. So you have to rationalize. And to rationalize this one, we're going to multiply by the conjugate of the denominator in the top and the bottom. And the conjugate is the exact same thing as the denominator, okay, except for an opposite sign, okay? So now we're multiplying out two binomials here. So 3 times 3 is 9. 3 times negative square root of 3 is negative 3 square root of 3. Negative square root of 3 times 3 is negative 3 square root of 3. And negative square root of 3 times negative square root of 3 is going to become positive square root of 9, but square root of 9 is 3. Down below, we've got 9, a negative 3 square root of 3, a positive 3 square root of 3, and then a positive times a negative, so it'll be negative square root of 9, which is 3. Now we're just going to combine like terms, cancel anything out. So up top, 9 plus 3 is 12, and negative 3 square root of 3 minus 3 square root of 3 gets me minus 6 square root of 3. Down below, 9 minus 3 is 6, and these two are going to cancel. All right, final step, all three of our terms here are divisible by 6, giving me 2 minus the square root of 3. All right, now we've got sine of pi over 12. So now we're dealing in radians. So you have a few options here. You could change the radians to degrees and then use that unit circle, use those unit circle degrees. That would be fine. Another way to look at it is, well, you could take your typical like pi over 6, pi over 4, pi over 3. Let's convert them into over 12. So that's the same as 2 pi over 12. This is the same as 3 pi over 12. This is the same as 4 pi over 12. Now we want two things that either add or subtract to get me pi over 12. Well, you have two different options. You could use 3 pi over 12 and 2 pi over 12, or 4 pi over 12 and 3 pi over 12. Either way would be totally fine. You could also utilize pi over 2 as well. That's also a good one to utilize, but that's not going to be helpful. All right, if none of those work, you can, double each of these. You could triple each of these. You could keep working until you could find something that will work for you. So just for ease, we're going to use 3 pi over 12 and 2 pi over 12, because when you subtract them, you get 1 pi over 12. All right, but I'm going to reduce those. So 3 pi over 12, remember, is pi over 4, and 2 pi over 12 is pi over 6. So sine of pi over 12 is equal to sine of pi over 4 minus pi over 6. We're going to use the sine formula. Because we are subtracting, we'll make sure we subtract. So we'll have sine of pi over 4 cosine pi over 6 minus cosine of pi over 4 sine of pi over 6. All right, sine of pi over 4, of course, is square root of 2 over 2. Cosine of pi over 6 is square root of 3 over 2. Cosine of pi over 4 is square root of 2 over 2, and sine of pi over 6 is 1/2. All right, feeling very familiar, except for the sign in the middle. So we'll get square root of 6 over 4 minus the square root of 2 over 4. Putting those together, we get the square root of 6 minus the square root of 2 all over 4. All right, so now for this one, it's a little bit different because it's in what we would call expanded form. And we want to see, okay, is there a way I can figure out my exact value and utilize these formulas? Well, the first thing you should notice is the pattern, right? So we've got sine, cosine, cosine, sine. Which one of these formulas follows that pattern? The sine. And because there's a minus sign in between, we know that we're going to have a minus sign in between our two angles. So I can rewrite this expanded version like this, sine 42 minus 12. And of course we can figure out, well, 42 minus 12 is 30. And sine of 30, we know that it's 1/2. So now we're going to do some verifying real quick. So tangent of pi over 4 plus theta equals 1 plus tangent theta over 1 minus tangent theta. So start on one side. Remember, when verifying, you have to start on a side. You cannot work both sides. Okay, so we know we're using the tangent formula. So let's rewrite the left using the tangent formula. So we're going to have tangent of pi over 4. It's a plus sign, so it's going to be plus on top, minus on bottom. Tangent of theta. 1 minus tangent of pi over 4 times tangent of theta. Okay. Now, tangent of pi over 4 is 1. We don't know what theta is, so we have to leave it as tangent of theta. And again, tangent of pi over 4 is 1, and 1 times tangent of theta is going to be tangent of theta. And oh hey, look, we just figured it out. Okay? All right, here's the next one. It's sine, so let's start over here. So we're going to follow our sine formula. So sine of the first angle times cosine of the second angle. It's a minus sign, so we're going to subtract. And then cosine of the first angle times sine of the second angle. You should remember that sine of 2 pi is actually 0. Cosine of 2 pi is 1. 0 times anything is 0. And 0 minus sine theta is going to be negative sine theta, which is exactly what we wanted. All right, last one. So look at the problem. Notice you have two sets of cosines. So we're going to have to expand twice. So this is going to be really long, but don't worry, it's going to condense. So we're going to start with the first one. Remember, with cosine, it's the opposite sign in the middle. So it's going to be cosine of 60 cosine of x plus sine of 60 sine of x. There's a plus sign here. Okay, let's do it again. Cosine 60 cosine x, because it's the plus, we're going to subtract. Sine 60 sine of x. All right. When you look along this, you should notice that you have a sine of 60 times the sine of x and a minus sine of 60 sine of x. Those two things are going to cancel each other out. Then you should notice that you have two of the same thing. You have two terms. So it becomes 2 cosine of 60 cosine of x. Now what's the cosine of 60? Well, 60 is the same as pi over 3, and the cosine of pi over 3 is 1/2. What's 1/2 times 2? Well, that's just 1, leaving behind cosine of x, which is exactly what we wanted. Okay, so sorry I moved the little thing. So we're happy.